Welcome to this CipherVibe Cloud Security Guide. Today, we will make how to secure an AWS environment step-by-step practical, prioritized, and connected to how real AWS environments are operated. Securing AWS is not one setting, one scanner, or one firewall rule. It is an operating model that joins account structure, identity, network boundaries, centralized logs, continuous detection, data protection, vulnerability management, and incident response. This guide turns the AWS Well-Architected Security Pillar and the AWS Security Reference Architecture into a practical checklist that security leaders, cloud engineers, and DevSecOps teams can use to harden an environment step by step. The purpose is not to memorize a collection of service names. It is to build a mental model you can apply when accounts, teams, workloads, and threats change. We will define the core ideas, walk through a repeatable security workflow, examine mistakes that frequently create exposure, design useful safeguards, and finish with a practical hardening roadmap. Throughout the guide, remember that cloud security work begins with authorization, scope, and evidence. Validate controls only in accounts you own or environments where you have explicit permission to administer. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for how to secure an AWS environment step by step. First, the account layer defines blast radius. Use AWS organizations, a dedicated management account, separated workload accounts, a security tooling account, and a log archive account instead of placing everything in one shared account. Second, the identity layer decides who or what can act. Require MFA, avoid long-lived IAM users, prefer IAM identity center and roles, remove unused access, and continuously analyze policies for unintended external or cross-account access. Third, the network layer limits reachability. Design VPCs by workload, restrict security groups and routes, remove public administrative access, use private connectivity where possible, and inspect internet-facing entry points. Fourth, the telemetry layer preserves evidence. Enable organization-level CloudTrail, AWS config across accounts and regions, centralized S3 log storage, and security service findings that defenders can investigate quickly. Fifth, the response layer assumes something will eventually fail. Prepare runbooks, delegated administrators, backup and recovery, key rotation, account isolation, incident roles, and tested communication paths before an incident begins. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Use diagrams whenever a relationship is difficult to explain in a sentence. Mark identities, systems, data flows, boundaries, and controls. A simple, accurate diagram is more useful than a crowded picture that implies knowledge you do not have. Now turn the mental model into a repeatable workflow. First, create or review the organization foundation first. Separate management, security tooling, log archive, shared services, development, staging, and production accounts. Then apply service control policies that prevent risky actions. Second, harden identity next. Lock down the root user, require MFA for privileged access, use federated SSO, replace static access keys with roles, scope permissions by job function, and review external access with IAM Access Analyzer. Third, build the logging baseline before making more changes. Enable CloudTrail organization trails, protect log buckets with strict policies and encryption, enable AWS config in every account and region, and send findings to the security account. Fourth, enable managed detection services. GuardDuty for threat detection, Security Hub CSPM for posture management and aggregation, Inspector for EC2, ECR, and Lambda vulnerability visibility, and Detective or Security Lake for investigation depth. Fifth, reduce exposure in workloads. Block public S3 access unless explicitly required. Require encryption in transit and at rest. Patch instances and container images. Protect secrets. Restrict ingress. And put WF controls in front of public applications. Sixth, practice incident response. Define severity levels. Preserve evidence. Isolate compromised identities or accounts. Rotate secrets. Restore from backups. Document decisions. And run tabletop exercises using real AWS service workflows. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. Document the result in plain language: what you observed, what you concluded, what you changed, who approved it, what evidence confirms the outcome, and what uncertainty remains. This disciplined loop, observe, interpret, decide, act, verify, and learn, appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, a single shared AWS account creates a large blast radius because development experiments, production systems, logs, keys, and administrator access can become entangled. Second, long-lived access keys and overbroad administrator permissions turn one leaked laptop, CI variable, or repository secret into cloud-wide control. Third, public exposure is often accidental. Open security groups, public S3 buckets, permissive bucket policies, unmanaged load balancers, exposed databases, and forgotten test resources create avoidable entry points. Fourth, missing logs make response slow and uncertain. If CloudTrail, config, DNS, VPC flow logs, application logs, and security findings are incomplete or mutable, defenders may not be able to reconstruct what happened. Fifth, security services can be enabled but ignored. GuardDuty, Security Hub, Inspector, and Access Analyzer need ownership, routing, severity rules, response playbooks, and regular review. Sixth, backups, KMS keys, and secrets can become recovery blockers if they are not protected from the same identities and accounts that an attacker may compromise. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Avoid absolute claims. Words such as secure, compromised, fixed, and compliant require scope and evidence. Prefer precise statements such as, "This control blocked the tested path under these conditions," or, "The available records show this identity used the service," but do not identify the human operator. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, use AWS organizations and service control policies to establish guardrails, then delegate security services to purpose-built accounts so teams can operate without giving every workload broad administrative control. Second, adopt least privilege with IAM Identity Center, roles, permission boundaries where appropriate, temporary credentials, MFA, access reviews, and automated policy analysis. Third, centralize logging into a protected log archive account, enable CloudTrail organization trails, configure AWS config across accounts and regions, and prevent unauthorized deletion or alteration of evidence. Fourth, enable GuardDuty, Security Hub CSPM, Inspector, IAM Access Analyzer, Detective, and Security Lake where appropriate, then aggregate findings and route them to owners with clear service level expectations. Fifth, protect data with S3 block public access, bucket ownership controls, encryption by default, KMS key policies, secrets manager, backup vault controls, lifecycle rules, and tested restore procedures. Sixth, make response repeatable through runbooks for root user compromise, access key leakage, public S3 exposure, GuardDuty high-severity findings, ransomware recovery, suspicious CloudTrail activity, and account isolation. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Design for humans. A safeguard that is impossible to use correctly will be bypassed. Provide safe defaults, understandable messages, usable recovery, and clear escalation. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Turn this guide into a focused AWS security hardening plan. Start by inventorying accounts, owners, regions, root user status, IAM users, access keys, public resources, CloudTrail coverage, config coverage, and enabled security services. Then fix identity risk, enforce MFA, remove unused IAM users and keys, document admin roles, apply baseline service control policies, and route security findings to named owners. Next, centralize evidence. Protect CloudTrail and config delivery, enable GuardDuty and Security Hub with organization auto-enrollment, and verify findings arrive in the security tooling account. After the evidence layer works, close high-risk public exposure, enable S3 block public access, review security groups and load balancers, turn on inspector scanning, and patch the riskiest compute assets first. Finally, protect secrets, keys, backups, and recovery paths, then run an incident response tabletop so account isolation, secret rotation, restore testing, and communication are practiced before a real event. Measure progress with percentage of accounts covered by CloudTrail organization trails, percentage of accounts and regions covered by AWS config, number of active long-lived IAM access keys, critical public exposure count, GuardDuty and Security Hub high severity, mean time to triage, backup restore success rate. Each metric needs a named owner, a reliable data source, a review schedule, and a known limitation. The strongest AWS environments are not secured by one tool. They are secured by an operating rhythm, separated accounts, least privilege, centralized evidence, continuous detection, protected data, tested recovery, and rehearsed response. Make the secure path the easiest path for builders and make risky actions visible before they become incidents. For chapter markers and primary AWS links, open the description. For more evidence-based cybersecurity research, visit CipherVibe.com and subscribe to CipherVibe. CipherVibe is operated by CloudSecTech LLC. Copyright 2026. All rights reserved. This briefing is general education. Validate controls with authorized administrators in your own AWS environment.